Okay, this video is going to focus on the idea of solving a system of equations. You've seen systems before, but maybe some of these systems you've never seen before. So here we go, beginning with this first example right here. Okay, we have one system with three equations and three variables. The goal is to identify x, y, and z. In this case, each equation has x, y, z, x, y, z, x, y, z. So when that's the case, pick on a letter to eliminate. For instance, look at the top two equations. Now, if you look at the top two equations, which letter seems to be the easiest to get rid of? How about we get rid of, let's say, the letter y. Let's focus on the y's in the top two. This is -2 and this is +1. If we multiply this by 2, it'll say 2y, which would knock out with this. So how about we multiply the top equation by 2, keep the middle equation the same. Ignore the bottom equation for now. So top equation by 2, copy and paste the middle. Here we go. Okay, so the top equation got doubled. The middle equation is as is. We did this because if you look at the y's, they eliminate if we add the equations. Let's add the equations. Let's knock out the y's. If you add these here, that'll be -x minus 7z, right? Minus 7z equals -13. So we have now an equation with x and z. We got rid of y. Let's do that again. Let's get rid of y again, but this time instead of the top two equations, focus on a different pair, either the bottom two or top and bottom. Let's look at top and bottom. Let's take the top equation, the bottom equation, and get rid of y again. How about we multiply the top by -3 and keep the bottom the same? Let's do that. So the top equation got negative tripled. The bottom stays the same because now the y's knock out. If you add the equations, let's add the equations. And so now we have another brand new equation with only x and z like before. So now let's take these two equations here and let these two equations form their own little team. Let's do that over here. And now let's play this game again, the idea of eliminating a letter. In this case, why don't we get rid of x? Because we can do that quickly by multiplying the top by 2 and leaving the bottom the same. And now we get rid of x's by adding the equations together. And this tells us that -4z is equal to -8, revealing that z is +2. Now that you know z, go back to either of these doubles to get x. How about we take 2 for z and drop it in there to quickly get x? Work out the algebra, and this reveals to us that x is going to be, it looks like -1. So now that you have x and now that you have z, go to one of the originals to find y. Maybe we'll go to the original top to discover y. And we've discovered that y is 3. Now you have x, y, and z. Present to them your answer in a formal fashion. So your solution can be presented as an ordered triple. Done, 100%. Let's move on. Now this example here, we have 3 equations, but the structure is different. In the top 2, you have x, y, z, x, y, z. In the bottom, it's just x and y. What letter is missing in the bottom? Z is missing from the bottom. So I would approach this problem as follows. I would look at the top 2 equations and get rid of z, because then you'd have only x and y like the bottom one. So eliminate z's. It's convenient that they're already 3z, 3z, so multiply either by a negative and add it to the other. So how about we multiply the top by -1 and leave the middle as is. Add these equations together, the z's knock out, and here is what we get. And now this equation with x and y can be interacted with this one here, and then we can find either x or y, and the rest comes tumbling down. So let's take these 2 equations and write them one on top of the other. And now here the y's line up perfectly. How about we just go top minus bottom? So let's actually subtract these ones in this case. Let's perform a subtraction. 6 minus 4 gives us 2x. And then let's go 6y minus 6y, so that's just 0. And then let's go 24 minus 20 to get 4. The 0y is gone, divided by 2. X is 2. So we have x. Let's go somewhere else nearby to find y, it looks like. Take 2 for x and plug it in there to get y alone. Let's do some mental math here. X is 2. 4 times 2 is 8. 8 away from 20 is 12. 12 divided by 6 is 2. So we just did mental math to find that y is 2. Now we need z. Go to, let's say, the middle equation to find z. And we can show that z equals 1. So our solution set, or our solution, would be 2, 2, 1. So let's go with 2, 2, 1 as an ordered triple. Let's move on. Now this system here is different from the others, because here it's x and z, x, y, z, and then x and y. The structure is way different. There are fewer letters. It looks like a smaller system. When that's the case, I ask myself, is there a letter that appears in all of them? Well, which one appears in all of them? Yeah, it looks like it's x, right? X and z, x, y, z, and x and y. So x appears in all of them. So why don't we rewrite this entire system in terms of x? Here's what I mean by that. Look at the bottom equation, get y alone. So let's move this to this side. So that'll say y equals 3 minus 3x. Look at the top equation, get it in terms of x. So why don't you solve for z? So why don't we move the 4x to this side first? So that tells us that 4z, negative 16 minus 4x. Let's divide everything by 4 so that z equals negative 4 minus x. And now what we can do is go to the center equation and everything becomes x. Watch. Keep x the same. Now instead of y, what could replace y? 3 minus 3x. Okay? And then we have minus 2. And then what replaces z? We have negative 4 minus x. And all this gibberish still equals 9 on the other side. Why don't we distribute? Distribute the negative 2. So we have x plus 3 minus 3x plus 8 plus 2x, still 9. And why don't you combine like terms? 1x, negative 3, that would give us negative 2. Negative 2 plus 2 would be 0x. 3 plus 8 is 11. And on the other side, you have 9. 0x disappears, so you have 9 equals 11. Whenever you have a system and it becomes a statement like this here, ask yourself, is this statement true or is this false? 9 equals 11 is false. And so the conclusion here is that this system of equations has, we say, no solution. There is no triplet of numbers, x, y, z, that if you drop them into this equation, into the system, that it would lead to true statements. Because if there were, we would have found them. So no solution because this is false. So now let's do an example that covers the other extreme case. Here we have xyz, xyz, xyz. All right, so maybe like the first example. Let's pick a letter and let's eliminate it. How about we look at the top two equations and let's get rid of the x's. So how about we multiply the top by negative 3 and leave the middle the same. So negative 3 top, keep middle the same. So the top negative 3 distribute all the way across. The middle stays the same. Add them so the x's are gone. So we get 10 y's and then we get negative 14 z's equals 16. So we got rid of x. Let's do that again. Let's say with the bottom two equations, get rid of x. So maybe multiply the middle by 2 and leave the bottom the same. Let's see, so the middle equation got doubled. And the bottom stays. Yes, it does. Now the x's knock out. So add these equations so that the x's are gone. And this is negative 5y plus 7z equals -8. And now let's combine these two equations together. So let them form their own little system somewhere off to the side. So here, how about we focus on the y's? You want the y's to knock out. How about we multiply the bottom equation by 2 and leave the equation above it as is? So the top equation stayed, the bottom got doubled. Now add all the things together and let's see what happens. So the y's knock out. Oh, the z's knock out as well. There is nothing left on the left. And on the right, those knock out as well. So we're left with 0 equals 0. Unlike the previous example that was false, this is true. This is always true. And what that means is that this original system of equations has what we call infinitely many solutions. So there are many ordered triples that work for this system of equations, right? There's a lot of different answers to this system here. You don't have to find any of them. You just have to classify this as infinitely many solutions. And it's not only because it was 0 equals 0. If you do a math problem and it ends up being like 4 equals 4, then it's the same conclusion, that your system of equations has many different answers. Okay, now let's wrap up this video with one final example. All right, this type of problem I'm fairly certain you've never seen before. Here we go. The goal here is to solve in terms of z. What that means is at the end of the day, your answer will have only z's. No x's, no y's, all z's. If you have 3 letters, you got to have at least 3 equations. So getting a specific answer is not possible. We can get an answer, but it's going to possess letters. And in this case, only z's, because that's how they want the answer presented. So why don't we do this? Why don't we open up an answer key down here at the bottom and make room for 3 spots, right? For x, typically it's x, y, and z. But we know that whatever you put in the x's has to be only in terms of z, the same here and the same here. And since it's in terms of z, go to the home for z and literally just put z. So how about we go and let's see here. What if we have x, y, z and then x and z? So there's no y in the bottom one. What if we actually make this equation simpler by reducing everything by 3? We haven't used that trick at all, but that's a trick you can always do. Let's shrink all of these by 3. So the top equation stays the same. Okay. And then divide everything by 3. So that's x plus 2z would equal 5. And then why don't we add these equations together? Let's see what happens if we add these equations together. Let's see, negative x and x are gone. Y plus nothing is still y. 1z plus 2z is 3z. And this would be 9. And then why don't we get y alone by moving 3z to this side? So y would equal 9 minus 3z. And now we got something to drop in the home for y. Usually y goes there. So what does y equal? 9 minus 3z. You see that? It's in terms of z. And now let's finish this by going here and putting something there in terms for x, but it's in terms of z. So why don't we look at the original equation? Or heck, why don't we actually just look at the bottom equation? Why don't we just move this to this side there? Watch. Move that over to that side. So that 3x would equal 15 minus 6z. And just divide everything by 3. So x would equal 5 minus 2z. And since that's what x equals, it goes here, and we are done. You have x, y, and z, but all in terms of z's. So pencils down, just listen up and watch. I want this to make sense to you. What I want you to see is how you can use this to get answers. So here, z is the main character. Pick your favorite number. I don't know what it is. Just pick any old number. Let's suppose that your favorite number is 1. So pretend that z is 1, okay? If z is 1, then plug 1 in for z everywhere. Z is 1, take 1 and plug it in there. That'd be 5 minus 2, which is 3. Look in the middle. Z is 1, put 1 there. 9 minus 3 is 6. What that means is that 3, 6, 1 is the solution to this system of equations. If you take 3, 6, and 1, plug them in for x, y, and z, there and there, you'll get true statements. Now, what if your favorite number is 2? Well, plug 2 in for z, and you'll get a different ordered triple that also works for this system. We could do this all day long, but you want to leave it in terms of z because that's what the directions requested. You can expect to see one like this on your solo quiz Tuesday morning. If you have any questions, let me know. Have a wonderful weekend. See you guys in a few days. Bye.